Rookie. Rookie. What's it doing? Bum, 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 bum. Okay. Hello, hello, hello.
How you doing, sir?
Hey, good evening.
Good evening.
How's everything?
I'm good, sir.
Good afternoon, everyone.
Hey, good afternoon. Couple minutes shy of good evening.
All right. Let's find my highlight.
All right, it looks like we might as well get started here. How's everybody doing tonight?
Good, how are you?
All right.
Good.
All right, so Monday I sent out the homework, the answers for homework 1 and the questions for homework 2. Did everybody receive that?
Yes.
Excellent, excellent. So no communications problems there, right? No communications problems there, right? All right, good. All right, good. I don't know why I got an echo here, but we'll figure out who that is. We'll shut them off. How's that sound? We'll figure out who that is. Shut them off. All right. So last class we started on boilers. I pretty much covered a lot of material. I just like to kind of recap, make sure that everybody's on board. When we met last, I told you basically in the boiler world, there's 2 types of boilers, fire tube and water tube boilers. Basically, I told you the difference. One of the questions on the state exam is, what's the difference between a fire tube boiler and a water tube boiler? So in a fire tube, the products of combustion are inside the tubes, surrounded by water. And in a water tube boiler, the products of combustion are outside the tubes, with the water being in the tubes. All right. Generally speaking, water tube boilers are much larger, higher pressures, higher capacity, and they're all fuel capable. Fire tube boilers today can only burn oil or natural gas. All right. And that's about as far as that's going to go. All right. They don't have any real questions about the direction of axis, other than all fire tube boilers today are considered horizontal boilers. All water tube boilers vertical. All right. You and I are only interested in stationary boilers. Occasionally, the boilers in our facility will break down. They'll bring in portable boilers, set them up in the parking lot as a temporary means of supplying steam until we get our boilers fixed. All right. You and I have nothing to do with marine boilers. All right. Those are boilers on ships. All right. There is only one externally fired boiler that we talk about. That is the HRT. The HRT boiler was externally fired. The fire was below the shell of the boiler. All right. All other boilers today are internally fired. All right. And you and I are only interested in high pressure boilers. Low pressure boilers, you don't need a license. They're used primarily for heating, hot water. You don't need a licensed operator. All right. Showed you a picture of a modern fire tube boiler. I hope today you'll recognize it. Its most distinguishable feature is that there are bolts that holds the front heads in place with big hinges, and these doors swing open, giving us access to the tube sheet, where if you're unlucky, you'll be forced to punch the tubes. All right, send a wire brush through them. All right, everybody kind of gets that. All right. The rear of the boiler, same setup, a hinge door that swings open, allowing access to the rear tube sheet. All right. I gave you a couple pictures of water tube boilers. All right. Today, most water tube boilers only have a single mud drum and a single steam and water drum. All right. You know, the old Sterling boiler had 4 drums. They figured out that wasn't necessary. All right. All right. So, I mean, overkill, but any questions about that stuff? All right. Everybody kind of gets that. All right. Oh, good. All right. All the boilers that you and I are going to operate are probably going to be natural circulation boilers. All right. That works on a simple premise that there's a temperature differential between the water entering the boiler and the heated water already in the boiler. All right. Everybody gets that. Heated water is less dense. It rises. Cool water is more dense. It sinks. That creates the natural circulation. All right. Every now and then they'll beat up a third engineer and ask him, can you name the 3 types of circulation that they use in boilers? For those guys, it's natural circulation, controlled circulation, and forced flow. All right. But if you're a second fireman, they're not going to ask you that. So don't worry about that. All right. Boilers are classified by draft. Up till about 1900, all boilers were natural draft. They didn't have any fans. The stack, the smokestack, all right, controlled airflow through the boiler. All right. Now, on the state exam, they have one question about natural draft. All right. And the question is worded exactly like this. In a natural draft boiler, how do we control airflow? And the answer is going to be the height of the stack, inlet dampers, and outlet dampers, or all of the above. What do you think the correct answer is?
All of the above.
Height of the stack.
All of the above. Does everybody get that? All right. If I close either one of these inlet or outlet dampers, am I going to get any airflow through the boiler? You get the idea. All right. So I need dampers as well as the height of the stack to produce natural draft. That's the only question they got on natural draft. All right. So I'm pretty confident you'll get that one right. All right. All right. All other boilers use some form of mechanical draft, fans to control airflow through the boiler. All right. And we'll get into this in much more detail when we talk about combustion. That's where that belongs. All right. I told you a little bit about boiler operations. All right. It's not an exciting field. All right. This is pretty boring business. All right. Does anybody do this for work? Operate boilers?
Yes.
All right. Would you agree with me that it's kind of boring?
I sit down for 6 hours a day.
All right. And how long is a shift? 8 hours or 12 hours?
8, 12 if someone's off.
Okay. All right, good. All right. I want everybody to understand that a lot of places still run 8 hours, but it's pretty normal today to run 12-hour shifts. 12-hour shift sounds like it sucks, but it actually gives you more time off. All right. Does everybody get that? All right. Many plants work 3 or 4 12-hour shifts with the remainder of the week off. All right. So it's a pretty good deal if you can handle it. All right. All right. I told you that a lot of the jobs in this field, you work by yourself. All right. But the basic reason you're there is emergency operations. All right. All right. Richard, do they make you do any maintenance or anything like that?
Yeah, we do a lot of it. We keep getting seal failures on our feed water pumps, so we've been pulling those apart every like 2-3 weeks for the past few months, and we like replace like if we make pipes and replace pipes and all that kind of stuff.
Okay, cool. All right. So, yeah, you have an opportunity to keep busy if you want.
Right.
All right. So again, don't get into this thinking you're gonna have an exciting lifestyle. It's pretty boring stuff. All right, remember what I told you, 99% boredom, 1% terror. All right. You might never see the terror part, so at least you got something to look forward to. So what my intention was here was to introduce you to the different types of boilers, hopefully with the premise that if you see a picture of it, you can identify it. All right. You can tell the difference between a fire tube boiler and a water tube boiler. All right. You kind of get how they're utilized, different segments of the field, and some of the terminology we use in the business. So that was my plan for Monday and tonight. On the early boiler, specifically the vertical fire tube boiler, there are only 2 questions in the state database about vertical fire tube boilers. One of those questions is, can you name 2 types of vertical fire tube boilers? And of course, they are the dry top, also known as the exposed tube type, and the wet top, sometimes called the submerged tube type. Those are the 2 types of vertical fire tube boilers. All right. Compared to other boilers that I've shown you pictures of, the main characteristic of this boiler is that it occupies very little floor space. It's a vertical boiler. Does everybody get that? All right.
So you had exposed tube type, and then the other one was
The
submerged.
submerged tube type. You should have this page in your handout. Do you guys have this page? Yeah,
Yep, there it is.
they should be labeled anyway. And that's it. That's the only question you're gonna see about vertical fire tube boilers. Any questions about that? Now, these things were dogs. They were about 30% efficient. The hot combustion gases made 1 pass through the water, and then they went out the stack. All right. The next boiler to come along was the HRT boiler. All right. Their favorite question for this puppy is, what does HRT stand for? All right. Does anybody remember?
Horizontal return tubes.
Excellent. Horizontal return tubular. And basically what happened in this boiler, you built a fire right here. The products of combustion traveled along the bottom of the shell, went through the tubes. Basically, the flue gas made 2 passes in the boiler. All right. Brought the efficiency up to about 50%. Still a dog with fleas, but better than the vertical fire tube boiler. All right. Now, one of the state inspectors' favorite tricks is when they get you in the oral. They have this picture. They have this picture. All right. And they got to ask you, what type of boiler are we looking at? All right. You could say it's a fire tube boiler, but what they're looking for specifically is what?
Horizontal.
HRT, horizontal return tubular. All right. Does everybody kind of get it? All right. And you can see over the years how the technology improved. When they first invented this shell, which was filled with water, rested on these lugs on the brick setting. All right. That created a lot of weight on the brick setting, and the boiler had a tendency to settle. All right. Years later, they figured out if we hang the shell by overhead suspension, we'll take the weight off the brick setting and we won't have those problems. All right. So the preferred method of installing one of these HRT boilers is by what they call overhead suspension. All right. Makes sense. It should make perfect sense to you. All right. One of the things that saves your ass is this. We no longer build boilers or pressure vessels using riveted construction. All right. Today, all boilers are welded construction. All right. Now, that's important because depending on the type of riveted joint they used, all right, the efficiency was all over the place, anywhere from 50% all the way up to 88%. All right. Does anybody remember what I told you about welded joints, what the efficiency of a welded joint was?
100% or 90%?
Excellent, excellent. 100% if you match the welding rod to the tensile strength of the material that you're welding, then the weld will be as strong as the material. All right. If you do not grind the weld flush or you leave the backing piece in place, the weld is 90% efficient, which any welding they do in the field is more than ample. All right. 90% is close enough for government work, is the expression they use. All right. Does everybody get that? All right. Riveted joints, the early riveted joints. The first one they come up with was what they called a lap joint. And basically, the plate overlapped and they put a rivet through it. All right. That created unequal thickness where the joint is, and it led to unusual stress. How they improved upon this, they had the plate butt up against each other, called a butt joint. And then they'd use straps and put rivets through it to increase the efficiency of the joint. But this also created that problem of unequal thickness. All right. So the lap joint and the butt joint were the two types of riveted joints. All right. Just so you know, I don't think they're going to ask you this anymore. We no longer build stuff this way. We've moved on to bigger and better things. All right. The one question that comes out of that whole welding thing is, what are the two most important welded joints on any boiler? All right. The longitudinal joint is the welded seam that runs the entire length of the shell or the drum, and that forms the cylinder. The circumferential joint is how they attach the heads to form a closed vessel. All right. So the longitudinal joint and the circumferential joint. We already covered that.
Are there any welds on a water tube boiler?
Yeah, a water tube boiler, when they form the drum, it'll also have a longitudinal joint, and it will also have a circumferential joint attaching the heads to the drums. All right. The difference is the thing that holds the water in a fire tube boiler is called the shell. In a water tube boiler, it's known as a drum. That's the only You know, it's a subtle difference, but it's a difference nonetheless. All right. All right, when they install fire tubes, there's two procedures. They expand the tube into the tube hole to make it tight so water doesn't leak out. And they bead the ends of the tubes over. So the tube itself acts like a stay. All right. Now remember, and this is a key point, they're going to ask you this 3 or 4 times on the test. One of the fundamental differences between fire tube and water tube boilers is that the fire tube boiler has flat surface that need to be supported. All right. One of the versions of the questions, if you look at that early vertical fire tube boiler, you'll notice the area around the furnace is a water leg. In other words, there's water in there under pressure. The furnace itself is a flat surface. So it has to be supported with stables. Any stay that's less than 8 inches long is called a stable. Any stay longer than 8 inches is just referred to as a stay. All right, that's the difference. Stay bolts are usually threaded. The stays in a boiler can either be diagonal stays or through stays that go all the way through the boiler. All right, that's the difference. All right, we use diagonal stays above the tubes to allow access through the manhole into the boiler. All right, that's it. I told you eventually somebody came along and improved upon the design of the HRT by placing the furnace inside the shell. The Scotch Marine boiler was considered an internally fired boiler. The furnace was inside the shell of the boiler. Remember, what was the only externally fired boiler?
HRT.
The HRT, you got it. All right. That's one of the state exam questions. What's the difference between the HRT and the Scotch Marine boiler? All right. Obviously, the Scotch Marine boiler was most popular on ships because you didn't need the brick setting, less weight. It occupied less space, which is important on a boat. All right. All right. Those boilers led to the development sometime around the 1950s of the modern package fire tube boiler. If you see a fire tube boiler today, this is what you're looking at. All right. If you're in Massachusetts, there's a pretty good chance that it's Cleaver Brooks. All right. Has anybody ever seen one of these? All right.
Yeah, I have a cleaver at my work.
Yeah, they're either painted green or blue. All right. They're not very creative in their color scheme. Every now and then you get some smart ass that paints it silver or puts a racing stripe on it. All right. But that's the basic color scheme when they come from the factory. All right. All right. All right. Now, the only thing they're going to ask you about this is these boilers today, all right, are almost completely automatic. You turn them on when you want steam and you shut them off when you're done for the day. Otherwise, they cycle themselves, they turn themselves off and on. They supply steam based on pressure, all right? They can only burn oil or gas. They cannot burn solid fuel. So you can't throw garbage, wood, coal, whatever you got laying around the yard into these boilers, all right? They're pretty limited in their size and capacity, all right? They're difficult to inspect, repair, all right? But they satisfy most of the needs in a lot of applications. So they're very, very popular, all right? All right. Now, what does all this mean? Can you identify by looking at a picture the 4 types of fire tube boilers we identified today? The vertical fire tube, the HRT, the Scotch Marine, and the modern package boiler. If you can do that, you basically got it licked. All right. Everybody got it? All right. Good. Any questions? Water tube boilers were developed, all right, because they can produce steam at higher pressures in greater capacity. We can build these boilers bigger, all right? They have no limitations, all right? Some of these boilers operate as high as 5,500 PSI, all right? That's high pressure. We had one boiler at Brayton Point that made 4 million pounds of steam an hour. All right, that's huge. The Plymouth nuclear reactor, it made 8 million pounds of steam per hour. All right, that's a lot of steam. All right. All right. They can build a water tube boiler to fit whatever space you got. All right. They have package water tube boilers. They're mounted on the back of a trailer. All right. They can drive one right up to your plant, hook it up, run it from the parking lot. All right. But the big thing that you're going to get asked about is water tube boilers can be hooked up with integral superheaters, air preheaters, and economizers. These are heat recovery equipment that improves the overall efficiency of the boiler. All right. But the big deal with water tube boilers, you can burn any fuel you got. So if you go to a trash plant, there's about 10 of them in the state of Massachusetts where they burn garbage. All right. The boilers there are going to be water tube boilers. Big boys. All right. They hold a lot of trash. All right. One of the bad things about getting a fireman's license, the record of you getting a license is public record. And these companies that own these trash plants send out mailing lists and they try to recruit you to go to work at one of their plants. All right. This work sucks. It's very hard. All right. Does anybody here work at a trash plant?
Yeah, I do.
Tell us about it, Nick.
Well, I work at CMS, Covana.
Okay. Are you on the fuel side or?
I'm trying to go to the power side, obviously now. So yeah. I'm on the fuel side.
Okay.
It's
And
humbling.
what appeals to you about the power side? More money?
Yeah, that's really.
Yeah.
Yeah.
Yeah, that's it. That's it. So what Nick does, he works on the fuel handling side where they bring the garbage in, they dump it on a floor, basically push it onto conveyor belts. All right. Pass it through shredders and it gets fed into boilers. All right. Remember, to run the high pressure boilers, you got to be a licensed fireman or higher. All right. So Nick wants out of the garbage game and into the power generation game. All right. Good luck to you, Nick.
Yeah.
I started that plant up. I only made it for 2 years.
Oh, really?
The smell of garbage eventually got to me.
I don't even smell it anymore.
Yeah, well, that's what people tell me. You know, they say, yeah, you get used to it.
Yeah.
I remember I bought a brand new Jeep and I used to leave work and I'd get home and the kids would get in my car and they'd say, this thing smells like garbage.
No, that-
So there's a couple of, pictures of different types of water tube boilers. All right. One of these pictures is the inspector's favorites. This is the Sterling 4-drum boiler. Okay. Everybody gets that. There are 3 steam and water drums, 1 mud drum. All right. But this is the boiler. They often ask you to explain your understanding of natural circulation. All right. In this boiler, the fire would be in this area right here. The tubes closest to the fire, the water gets heated first and it rises up. All right. The entering feed water enters the rear drum. And because it's cooler and these tubes are furthest from the fire, there's a downward motion in that water. That rising and sinking motion of the water is what creates the natural circulation in the boiler. All right. Any boiler where the water rises, those tubes are referred to risers. All right. Any boiler where the water descends or sinks, those tubes are known as downcomers. All right. Does that make sense?
How does the middle top tube function?
The middle, well, what happens in this particular boiler, if you have to look at this close, but if you look at these 3 drums up top, the rear drum here is not connected on the water side to the other 2 drums. So the water has only one way it can go, down. All right. There are equalizing tubes on the steam side to equalize the pressure between those 3 drums. So they're all at the same pressure. All right. But there's no path for the water to short circuit. So it has to flow downward. All right. That water then rises up these tubes into the front drum, passes over to the middle drum where the steam takeoff is. Any water remaining sinks back to the mud drum. And the whole process is continuous.
All right, thank you.
All right. All right. And if you get that, that's probably one of the more common ways they ask that question in the oral exam. Explain that. All right. And if they bust your balls, he forgot this picture. They usually have this exact picture in their drawer. Remember, you can do this. You can create your own boiler with a piece of paper. All right. Put your 3 drums, your mud drum, and label them the rear drum, the center drum, the front drum, and the mud drum. Feed water enters the rear drum. It flows to the mud drum through the pipes, tubes known as downcomers. Then it flows up to the front drum, over to the center drum, and back to the mud drum. That is the natural circulation in a Sterling boiler. It's that simple. All right. Shouldn't take you more than 5 minutes. There's actually a ton of these boilers still around. I don't know if anybody's familiar with when you go into Boston, right at just about South Station, there's a plant there known as Nealon Street. All right. They have 3 of these Sterling boilers that were built in 1929. They supply steam to over 250 customers in the city of Boston, basically on a daily basis. Those boilers are, 90 years old. All right, everybody kind of get that? They take care of them, so they've lasted a long time. All right. As I mentioned earlier today, they figured out we don't need multiple drums in boilers anymore. Most boilers today are configured with a single mud drum and a single steam and water drum. All right. The only real difference today, the modern boilers utilize water wall construction. The walls, the floor, the ceiling of the furnace area is all constructed of small diameter tubes filled with water. All right. In fact, if you looked at a modern water tube boiler that you bought today, every square inch of the boiler would be water wall heating surface. Water walls are exclusive to water tube boilers. Fire tube boilers do not have water walls, so it makes that pretty easy. All right. Again, they can make water tube boilers as large as necessary. All right. So you can build this thing as big as your money dictates. All right. And depending on the fuel that you have to burn. Many of the trash burning boilers today are adapted from coal burners. All right. So it's the same technology, the same type of boiler. All right. CMAS is a little different in that they pulverize the garbage and they inject it into the furnace, where in theory it burns in suspension. Right? It's supposed to be a more efficient way than just a mass burn type of technology. Right? I told you last class that the difference between fire tubes and water tubes was the way they separated moisture, water from the steam. All fire tube boilers, how do they do it in a fire tube boiler?
Dry tube?
The dry pipe. All right, the dry pipe is used to separate moisture. In a water tube boiler, they use cyclone separators and baffle plates, sometimes called scrubbers, all right, to separate the moisture from the steam. I showed you this picture of a couple of cats working in the Philippines. Obviously, they don't have OSHA standards for their people working in the boilers. They don't have any safety equipment on, but now this page, I don't even think you guys don't have this page in your binder, do you? All right. This just explains one basic thing that I think you all understand. A pressure vessel, all right, should be in what shape?
Oval.
Round. All right. The early boilers, the heads on the water tube boilers were dished to a segment of a sphere, kind of a semicircle. All right. That kind of evolved into a flatter profile, kind of a half an ellipse, they called it, or semi-ellipsoidal. All right. Today, if you look at modern boilers, they have what they call full hemispherical heads. They're perfectly round. All right. That's the shape the pressure wants to push them in. All right. Remember, what's the problem with a fire tube boiler?
Good flat surface.
It has the flat surfaces. Is that a good idea for a pressure vessel?
Mm.
No, because the pressure wants to make that flat surface bulge out. All right. So it has to be supported or stayed. All right. So that was just put in there to help you kind of grasp that. Okay. All right. We already talked about how you figure the inside diameter if you're given the wall thickness of a tube. Remember, all tubes, they give you the OD. So a 3-inch tube, they're talking the outside diameter. If they tell you it's a 3-inch tube with a 3/16 wall thickness, then you're expected to be able to calculate the ID, all right, or the inside diameter. Any questions about this? Yeah, it's pretty simple math. All right. Now, we talked about what happened at Salem Harbor, right? So we don't have to go over this again. All right. Boiler incidents are few and far between. Almost 100 years between the last pretty serious boiler accident. Did anybody ever hear of that story of Morse Shoe in Brockton, Mass? If you know Brockton, the Morse Shoe Company was right downtown. It occupied about 3 blocks of downtown Brockton. In 1910, they had done a hydrostatic pressure test on one of the boilers. And to do that test, they had to gag the safety valves. All right. So the safety valves wouldn't open during the test. They did the test on a Saturday. When they wrapped it up for the day, they forgot that the gags were still on the safety valves. A different crew come in Sunday night, started the boilers for Monday morning. And right about 7 o'clock in the morning, when everybody was punching in, coming to work, the boiler exploded. All right. It took out 3 blocks of downtown Brockton. All right. Killed a bunch of people. All right. And it was a pretty big disaster. Right. The only interesting thing of the story is the chief engineer, he lived across the street in a house owned by the Morse Shoe Company. All right. They never found his body. All right. Now, for years, him and his wife didn't get along. So the rumor for years was he used that opportunity to disappear. I'd like to think he got away with it, but we'll never know. All right. But so that was the last really tragic accident before Salem Harbor happened in 2007. Right.
Is it standard operating procedure to gag the safety valves when you?
It is. Because remember, you have to bring the boiler pressure to 1.5 times the maximum allowable working pressure. The safety valves would open well before that. All right. So you either remove the safeties and put a blind flange or gag them. And we'll talk about that. I'll show you what those devices. A safety valve gag looks like a gear puller, a wheel puller, if you've ever seen that type of tool. But anyway, now, the only thing they're going to ask second firemen is, what is the biggest heat loss in a boiler? All right. Generally speaking, the back of the envelope calculation is that 10% of the available heat in the fuel goes right out the stack. All right. If you're going for your 3rd engineer's license, all right, there are 7 losses in every boiler. All right, whether it's your home heating boiler or the largest industrial boiler, all boilers have these 7 losses. All right. For third engineers, you need to know this list, but you can still see that the heat loss out the stack is still number 1. That's the biggest heat loss in any boiler. Any questions on this? Now, one of the terms that I want you to learn here tonight is boiler heating surface. All right. All right. This allows us to compare one boiler against another. All right. The boiler with the greater heating surface can produce more pounds of steam per hour. It's that simple. More heating surface, more steam. They're not even going to get that far. For second fireman, the only thing they're going to ask you about heating surface is, can you define it? All right. The ASME code says heating surface is defined as the parts of a boiler with water on one side and the products of combustion on the other side. It's always measured on the hot gas side. That's the side receiving heat. And it's always expressed as square feet. Now, that being said, one of the math questions on the state exam is, can you calculate the heating surface of a tube?
Yes.
All right. So tell us, Dave, how would you calculate the heating surface of a tube?
Assuming that the fire side is on the inside of the tube, because it's a fire tube, I can take the outside diameter of the tube, to subtract the difference of the tube thickness. That will give me my inside diameter. The length of that multiplied by the diameter will give me my square foot in area.
Okay, almost. But let's do one, all right, just to make sure. All right, let's say I had, and we'll make it easy for this example. We got a water tube, 3 inches in diameter.
Yep.
And that tube is 14 feet long. What is the heating surface of that tube? So according to Dave, we're first going to deal with
Pi, right? Pi's
What?
got to be there.
excellent. We're going to multiply the diameter times pi.
Right.
And they tell you on the state exam to use 3.14 as pi. All right. Does everybody remember that?
Oh, what is
Close
the,
enough for, what's that?
what does the HS stand for?
Heating surface.
Oh, okay. All right.
All right. So that's going to give me 9.42.
Are you using that as a water tube where the water's inside
Yep,
and the fire is on the outside? 'Cause
right.
If you did it on fire tube, it would be just the opposite, wouldn't it?
That's correct. This is a water tube example,
Okay.
and I should clarify that. All right. So once I figure out the circumference of the tube, that's the distance around the tube, I now have to multiply it by the length. But I've got one problem. All right. I cannot multiply inches times feet. All right. So what to do?
Convert feet to inches or.
I could convert feet to inches, but
Or inches to feet.
yeah. And Dave, I tend to be lazier than the average person. So I'm going to take the path of least resistance and I'm going to take 9.42 inches and I'm going to divide it by 12. And what's that going to give me? Feet.
3.33.
Close. How about 0.785? And then I can multiply that
I'm thinking.
by 14 feet. Everybody buy that?
Yeah.
Are they
And
gonna
that's
allow,
gonna-
are they gonna allow to use calculators and stuff like that on the state exam?
They do allow you to use a calculator. All right.
Do you have to bring your own or they provide one?
No, you got to bring your own and they want to check it out to make sure that you didn't bring a word processor or a laptop. All right. And also, what shouldn't you bring to the state test?
My state book?
Your cell phone.
Oh,
All right. There are no lifelines. You can't call for help. You can't call me in the middle of the test and say, hey, Tom, you wouldn't believe this question I just got. Can you help me out? All right. That's not permitted. All right. So in this particular case, each tube is 10.99 what?
Square feet.
Square feet. Excellent. If they went on to tell you that there were 110 tubes in the boiler, what would be the total heating surface of all those tubes?
times 100.
Yeah, times 110 tubes, right? Each tube is 10.99 square feet times the number of tubes. That would be the heating surface for all the tubes. All right. That's an example of the math they're going to ask you on the state exam. All right. Basically what you and I would refer to as third or fourth grade math. All right. All right. And that's when you last did this, probably. All right. Unless, does anybody have a job where you actually do math all day?
Not all day, but I get into it.
Do you? Yeah, that's cool. So at least it keeps you current, keeps you sharp, right?
Yeah.
All right. And we'll talk more about this. Like I said, one night, we're gonna just do all the math that's on the second fireman's test. So you'll be well versed in this stuff. All right. For third engineers, to see that you understand this concept, they might ask you, how would you calculate the heating surface of an HRT boiler? All right. And what they're asking you to do is look at the boiler, see which components of the boiler meet the criteria of heating surface as defined by the ASME. And you would understand that it's 2/3 the area of the shell, the area of all the tubes, and then 2/3 the area of the tube sheet minus the area of the tube holes. All right. So that's how you would calculate the heating surface of an HRT boiler. And I'll beat this up with the third engineers down the road. Second firemen won't get asked that question. All right. So if you're a second fireman, don't sweat this out. The only thing they'll ask you to do is calculate the heating surface of a tube. All right. Keep it simple. We'll come back to factor of evaporation, but let's talk about stress. This one I need you to write down. On the state exam, they're going to ask you, what is the definition of stress? The definition of stress is this. It is the internal resistance a material offers against an external force. I'll say it again. Stress is defined as the internal resistance a material offers against an external force. That's the definition they use on the state exam. Stress values are always given per inch of thickness. And they're always expressed as pounds per square inch. For instance, good old carbon steel, all right, might have a stress value of 25,000 pounds per square inch per 1 inch of thickness. This is important because they're going to ask you this. If I have 1/2 inch of that steel plate, what is the stress value now?
Half of it.
It is half of it. Very good. Does everybody get that? All right. If I had a plate 2 inches thick of that material, what would that do to the stress value?
Double it.
It would double it. All right. Does everybody get that? All right. The thicker it is, more better. All right. The higher the stress value. All right. All right. Is everybody good with this? So that's that question. What's the definition of stress? Now, in a boiler, the other question they have about stress is, what 3 types of stress are boiler components subjected to? All right. And you can see there, compressive, shear, and tensile stress. All right. All 3 of these types of stress are happening in a boiler. The top paragraph gives you a little explanation of what each of them mean. The bottom paragraph gives you an example of where you might find that particular stress in a boiler. That's enough about stress. Now, one of the things they won't ask you, but I want to explain to you because I've used this term before, is how do they calculate maximum allowable working pressure? All right. You know that the highest pressure that any boiler can operate at is its MAWP. All right. So what they do, they take the material that the boiler is made out of, and that material will have a tensile strength, the stress value that I just told you about. All right. You're going to multiply that by the thickness of the plate, T, times the efficiency of the welded joint. All right. That's how it's put together. And then you're going to divide this by the radius of the shell or the drum times a factor of safety. All right. The factor of safety represents a simple fact that boilers operate at extremely high temperatures due to the combustion that takes place and extremely high pressures. All right. So that factor of safety, 4 or 5, they divide that stress value, that upper calculation, to give them a safe margin. Does that make sense? For instance, if I took that same piece of steel and I built a bridge out of it, all right, I wouldn't have to use a factor of safety because my bridge will only be subject to ambient temperatures. Does everybody kind of get that? It won't be 1,000 degrees on my bridge. All right. All right. Does everybody see that? So that's how they do it. They're not going to ask you about this, but I just want you to get it. So it's a simple calculation that they do on every component of the boiler. When they find the lowest value, they use that as the maximum allowable working pressure for the boiler. All right. And just so you know, for the boiler to physically come apart, for the boiler to burst, all right, the bursting pressure will be the maximum allowable working pressure times the factor of safety. You and I should never see that. It can't really happen in reality. All right. So maybe your biggest fear was, I hope this boiler doesn't come apart on me. All right. It's very unlikely to happen. There's so many other things that'll trip the boiler.
The new boiler is more likely to burst than they're used.
What's that?
Am I reading that wrong? The new boiler is more likely to burst?
Less likely.
Oh,
All right. Think
Okay.
about it. When I divide stress value by 4, all
okay.
right, the number's bigger than if I divided it by 5.
Oh, right, right.
Yeah, used boilers have corrosion and other things going on with them. So, in fact, in Massachusetts, the insurance companies like to use 5.5 if you're in the habit of buying used boilers. You know, so they're a little shaky on used boilers, especially ones that are over 30, 40 years old. All right. But again, they won't even beat up a third on this. This is stuff they'll ask a first or second engineer. But I just figured you wanted to know why they use all these terms or these values. So. And again, these examples are just used for guys going for the higher licenses. All right, you can see that if I build a boiler, all right, out of tensile strength material that has a strength of 65,000 pounds per square inch, 1/2 inch thick, 82% efficient joint, a riveted boiler, all right, the maximum allowable working pressure is only 148 PSI. That's how dramatic the margin of safety is for boilers. All right. They know, probably the biggest thing that you can screw up a boiler is not bursting it, causing it to blow up, but it's overheating it. All right. Remember, your job is to keep water in the boiler at all times. That's paramount. All right. If you overheat the boiler, what happens? The boiler components expand. All right. As they expand, they become weaker. All right. And as they expand, something's going to fail. All right. So you'll probably get a tube failure. All right. Something well before the boiler actually bursts. All right. All right. Yeah. The number one cause of boiler failures is overheating. All right. You guys probably aren't in the habit, but there's a pretty good write-up of a low pressure boiler in Tennessee that was periodic or non-continuous attendance. All right. The mechanics replaced the check valve on the feed water line backwards. All right. One of the guys went into the boiler room to check on the boiler and there was no water in it, but the boiler was still running. All right. He opened the bypass on the feed water line and
Oh,
put cold water
oh,
basically into a cherry red hot boiler.
oh,
right. Basically what happened, a couple of the tubes failed. Now remember the construction of these fire tube boilers. The heads are just bolted on. So the steam pressurized both heads. One of the heads blew off, blew the bolts, sheared the bolts right off. And the boiler left the boiler room, went through the factory like a steam powered sled, all right, and ended up in the parking lot, all right. Nobody got hurt.
wow.
Kind of a miracle.
There's a video on YouTube that's pretty cool.
Yeah. The penalty the company got was they could not do their own maintenance anymore. They had to hire an outside firm to come in and do things like replace check valves. Now, if any of you are mechanics, you know that check valves have arrows on them that show the direction of flow. Right? So they've made it as idiot proof as they possibly could. You know, if you want the water to flow this way, the arrow should be pointing in this direction. So.
That's got to be one tough review to do.
Yeah, it's embarrassing, you know, because you know they were pretty self-sufficient. They had their own maintenance staff. They were humming along, fat, dumb, and happy until they did something stupid. Yeah, they also were kind of amateur electricians. And the other thing that hurt them is they wired the low water cutout backwards. All right. So, you know, they swapped the red and the black wires. And when the boiler should have shut the fuel valve when there was no water in it, it didn't do that either. So it just kept firing.
So that would be an interesting review. Well, you blew the boiler up out the plant and everything else. But the next year, you didn't do that again. So
Yeah. So yeah, that's basically it. So any questions on anything that we've covered so far? All right. All right. Again, I touched on a couple things that you don't have to know, but I just figured you'd want to know just as background information, you know. What they will beat you up on the test though is stress, the 3 types of stress. They'll ask that on the state exam. Heating surface, they'll ask you to calculate that. We'll talk about equivalent evaporation later. And of course, the biggest heat loss is in a boiler. All right, everybody gets that. All right. Now, just so you get where this is going, if the biggest heat loss of the fuel that I burn in the furnace is it carrying through the boiler and ultimately out the stack, all right, what move do I have to help me lower that exiting flue gas temperature? All right. The only thing they come up with is to put stuff in its path, in the path of the flue gas that will absorb heat. All right. In this particular picture, you see the superheaters. So as the hot gases leave the boiler, they pass over those superheated tubes and they give up some of the heat to the steam that's inside it. All right. As the flue gas works its way out, it passes over the economizer. That heats up the water on its way into the boiler. All right. Further reducing the temperature of what?
Of the exhaust gas.
The exiting flue gas. And then finally, I'm going to put the air preheater in the path of that exiting flue gas. And that's going to heat up the air that I'm going to use for combustion. And it's going to do that by further reducing the exiting flue gas temperature. So does everybody kind of get the object of the game here? All right, the more stuff that I can put in the path, all right, of that exiting flue gas, the lower my stack temperature, the greater the boiler efficiency.
Is there a limit on what you put? Because I would think you would have like almost a back pressure almost if you put too much stuff in the way.
Okay, that's an excellent point. And here's the problem, all right? And it's really only a problem with dirty fuel, all right? As that, let's make a simple here. I burn flue gas. I burn fuel in the boiler. It makes flue gas, which is now going to travel out the stack. All right. I want to put as many things, superheaters, economizers, air preheaters, in the path of that exiting flue gas to absorb the heat. All right. But if I burn a fuel that contains sulfur, all right, what will happen? The exiting flue gas will drop below the sulfur dew point. Condensation will occur, and the sulfur in the condensation will mix, forming sulfuric acid and lead to accelerated corrosion on these components, what they call cold end corrosion. Now, natural gas has no sulfur in it, less than 15 parts per million. All right. So the risk if you burn natural gas is non-existent. Now, you're exactly right. If I have ID fans, I'll have to size those fans to compensate for the restriction to flow. All right. So you're right on that aspect. All right. But the savings will more than justify the additional cost of the power for those fans. All right. All right. So does everybody get that? All right. Now, the fuels that are dirty are coal, oil, our buddy garbage. All right. As Nick knows, trash has a real high sulfur content. All right. Because it's made out of petroleum products. All right. Plastic. All right. Most of our garbage today is plastic. All right. And that's the problem in a trash plant. They have scrubbers that reduce sulfur gases from the flue gas. All right. And that's expensive just to run those. But that's how they meet the environmental laws. All right. So anyway, what we'll talk about next. We'll take a break here first, but what we'll talk about next is heat recovery equipment. And that should be a wrap for tonight. All right. Well, just make sure that I covered everything that's on the homework. It looks like I have, but why don't we go ahead and take about a 10-minute break at this time? So,
All right. Hey, Tom,
Yes.
do they do anything, certain materials and stuff like for conducting heat? Like, obviously copper is better than, some other metal and brass and bronze and things like that. And I assume those are taken into consideration for an extracting heat from the exhaust.
Yeah, I mean, a lot of the technology involving tubes that it might be used in an economizer or an air preheater or what they call extended surface tubes.
Yeah.
And a lot of that technology uses those alloys of copper, aluminum, but it's more in the rifling and the design of the tube to get laminar flow rather than turbulent flow. It's pretty high-tech stuff. We'll talk about the tubes a little bit later, but yeah, it's pretty interesting stuff, the metallurgy and all that stuff. I know brass and bronze have serious temperature limitations in boilers because they're a soft metal,
Yeah.
only good for about 350 degrees. So, you'll see brass plugs and stuff on low pressure boilers, but you usually won't see them on high pressure stuff, Yeah, there's quite a bit alloys and stuff like that. So yeah, it's all pretty interesting. All right, might as well get back at it here so we can wrap this up. Anyway, the next section in here is superheaters. All right. Superheaters are very easy for a second fireman. All right. The only one a second fireman to understand is how they make superheat. All right. And the best way for me to describe this is for you to look at this picture. All right. Remember, all boilers that boil water and make steam produce saturated steam. The only way we know to make superheated steam is to take that saturated steam and pass it through some tubes that are in the path of the exiting flue gas. As the exiting flue gas passes over those tubes, it gives up its heat to the steam, and the steam becomes superheated. All right. It's that simple. All right. All right. Does everybody kind of get this? All right. Now, the thing to remember is, unless I'm running equipment that relies on steam for propulsion like a steam turbine, then superheated steam is really not necessary in many applications. All right. So, for instance, where Dave works, whole market foods, just the temperature of saturated steam is enough to do what they're trying to do. All right, cook stuff. Is that basically what happens?
Yep.
Yeah.
It's used for helping to cook the meatballs.
Yep. So everybody kind of gets that. All right. So superheated steam is not used everywhere now, but the concept of how it's done should be pretty straightforward to everybody. All right. We have to take the steam out of contact with the water from which it was generated, and then pass it through a heat source. In this case, the exiting gas for the boiler, which we'd like to reduce its temperature. Okay. Now, there's another term in this industry called a reheater. And what happens in a reheater is this. After the superheated steam goes into the turbine, it does a little bit of work for us. When it does that work, turning the blades of the turbine, its pressure and its temperature are reduced. We then take the steam out of the turbine and send it back through a series of tubes that are once again placed in the path of the exiting flue gas. The steam then gets reheated back to its original temperature and put back in the turbine to finish the task. All right. So the question they have on the state exam is, what's the difference between a superheater and a reheater? And the difference is reheated steam has already done some work for us in the turbine. And that's it. Now, because Nick works in a trash plant, this is pretty typical of what his plant looks like. His boiler burns garbage to produce steam. That steam is superheated and sent to a steam turbine that drives the generator. Think about it, a trash plant has got the best of both worlds. People pay him to bring the trash there to get rid of it. And then they use that trash to produce electricity, which they sell. So they've got a couple of income streams, and most of those plants separate metal from the garbage, and they sell that as well.
Okay.
Right. So they get a bunch of income streams coming in. Right. Now, as you move up the ladder in this industry, superheaters become more of a thing, all right? And there's a bunch of things that have to be considered about superheaters. What I want everybody here to know is this. Using superheated steam improves the overall efficiency, all right, an average of 2 to 5%, right? But the real benefits are to the steam turbine, because there's less moisture in the steam, there's less erosion on the turbine blades, and because each pound of steam has more BTUs in it, you need less steam to do a particular job. All right. That's the big gain of using superheated steam. All right. If you're cooking meatballs, superheated steam isn't going to win you anything. All right. All right. Not a good thing. All right. Now, just so everybody knows, the location of the superheaters is considered fairly important. All right. All right. Is anybody here familiar with how heat is transferred? Go ahead, Dominic. Why don't you give me a shout out for that?
So heat's usually transferred, at least for, I'm doing this based off of, because I do HVAC, so gas furnaces. For us, the heat's transferred when the air goes over our heat exchanger, so any metal that we use. And as long as it's cooler, it heats up that air. That's how heat transfer works for us.
All right, how about this? What I was looking for was the 3 methods of heat transfer are radiation, convection, and conduction. Has anybody heard of those terms before?
Yep.
Yeah.
Right. Often in a boiler, the method that a particular device receives its heat is how we refer to it. For instance, In this picture right here, the fire is right here in the furnace. This superheater right here is what they call the radiant superheater. It receives the majority of its heat through radiation. It can see the fire, right? In much the way you and I can see the sun when we go outside and we look up at it. Don't look at it too long. Remember what your mother told you, all right? But you feel the heat of the sun on your face, right? All right, that's radiant heat, all right? The superheater that's over here, labeled the primary superheater, doesn't see the fire, but it receives its heat through convection, all right? The hot gases, as Dominic mentioned, flowing over it, all right? So those hot gases flowing over the superheater is how it receives the majority of its heat. That makes sense? All right. At any given time, radiation, convection, and conduction are happening in the boiler all over the place. That's how the heat is transferred, right? Now, superheaters that hang straight up and down in a vertical axis are called pendant superheaters, like a pendant necklace that you'd wear. Superheaters that are on a horizontal axis are known as plate superheaters, right? And then the only other difference is superheaters are also labeled as primary and secondary, all right? This one's pretty self-explanatory. The primary superheater gets the saturated steam first. And from there, it goes to the secondary superheater, all right? So that's pretty self-explanatory. Now, once you go up the ladder and you go for your third engineer's license, they'll start to ask you things like, how do they control the temperature of the steam? In this country, all right, the United States, the maximum steam temperature is about 1,050 degrees Fahrenheit. That's because the alloy metals that we use can withstand that temperature cost effectively. We can make materials that withstand higher temperatures, but it's not cost effective, all right? So we have to control the temperature of the steam, all right? These are all methods that help us control the temperature of steam. A temperator's combination of radiant and convection type superheaters, tilting burners, bypass dampers, flue gas recirc. Second firemen don't need to know any of those, right? Don't worry about it, all right? Later on, I'll talk with the thirds about having radiant and convection superheaters used together help you control the temperature of the steam. And how spraying water into the steam flow helps me control the steam temperature. All right. Well, we'll talk about that down the road with the third engineer. Second firemen don't care. Although, Nick, do you ever get a chance to go on the power side or no?
I just started going to the bins a little bit. They were training me. So,
Okay, good, good.
I
All
know.
right. Yeah, eventually, I don't know, you guys got boiler operators and auxiliary operators there still?
Yeah, that's what I'm trying to go do.
Yeah. So you're looking to become an auxiliary operator?
Yeah, that's
Yeah. And what, a third engineer is considered a boiler operator, or what's his title? Or assistant control room guy, or what, how do they?
They can get in the control room once you have your third.
Okay, okay, yeah. Yeah, it's a little different than when I started it up, but yeah. It's the same game, you know?
Were you at CMAS?
Yep,
Oh, really? Oh,
yeah, I worked for Bechtel, but that was 87.
okay.
And when they Bechtel, that's how they get their money out of it. They constructed the plant.
Okay.
And so they took the revenue for the first 2 years. And then the plant reverted back to the CMAS partnership. And that's when I bailed out. I said, I've had enough of this shit, you know?
Yeah.
But I remember the operators worked extremely hard. In fact, at one point, they had a rule there that you couldn't have a cell phone. I don't know if they still do that foolishness.
Yes and no.
Yeah, I don't want you to give away any secrets here, you know? But it's an excellent experience. You get a lot of experience at those plants.
Yeah, for
That
sure.
makes you more desirable in the field. So
So
when you're young, you don't mind the hard work for a little while.
Yeah.
It won't kill you, as they say. All right. All right. The next topic is heat recovery equipment, economizers, and air preheaters. All right. There's basically only one type of economizer. Basically, feed water entering the boiler comes from the deaerator and passes into a series of tubes that are placed in the path of the exiting flue gas. I think everybody understand what happens next. The exiting flue gas gives up its heat to the entering feed water on its way to the boiler drum. The object of the game is to heat up the water to the saturation temperature as close as possible, all right, without using any of the heat in the fuel. In other words, if I can get the water in the boiler already to the saturation temperature, then all I have to add is the latent heat to get it to become steam, all right? This thing is the greatest idea since whipped cheese, all right? With one exception. If you have a dirty fuel that has a lot of ash in it, these things become a nightmare. Because in that exiting flue gas, it contains ash. And guess where some of the ash is going to end up?
Between the pipe.
Between the tubes in the economizer. Then you get a leak in one of the tubes, all right? Because the ash contains sulfur, you get sulfuric acid, you get accelerated corrosion, which leads to more leaks, all right? Finding a leak in this tube bundle is problematic, as you can see. Many economizers have 300, 400, 500 tubes.
Ooh.
All right. Finding the one that's leaking or the group that's leaking is often very difficult. All right. I'm sure that economizer leaks is a problem at CMAS, Nick. All right. I don't know if you ever hear of the problems they have, but yeah, you will. Yeah. Does everybody get how basic this thing is? All right. The only question they're really going to ask you is this: what is the gain in efficiency by using an economizer? And you can see underneath that paragraph right here, I hand wrote a note,
Yep.
1% for every 10-degree rise in feed water temperature. That's what they want you to use on the state exam, right? So you get a 1% gain in efficiency for every 10-degree rise in temperature. The second device is what they call an air preheater. The air preheater they first come up with was called a tubular air preheater. This guy was beautiful in that it had no moving parts whatsoever. The hot gases leaving the boiler went inside the tubes and out the stack. The incoming combustion air traveled on the outside of the tubes and into the combustion chamber. All right. I preheated the combustion air utilizing the exiting flue gas. All right. The only problem with this puppy is if you use the dirty fuel, you'd have to clean it periodically. The ash would accumulate inside the tubes. So you had to punch the tubes, right? Before I went to work at CMAS, I worked at the General Motors car factory in Framingham. We had 4 boilers with tubular air preheaters. When I was a young kid, the chief said to me, "How'd you like some overtime?" And being a stupid young kid, I never asked, what exactly will I be doing? And what he had me doing was punching the tubes in the air preheater. The tubes were 80 feet long, all right? And what he told me to do was stand up here, force a brush through each tube, and then when the brush came out the other end, pull it back through the tube. I did 3 tubes. I thought my arms were gonna fall off. All right. It was the stupidest thing I ever did in my life. All right. There were 400 tubes in that air preheater. All right. Later on, I thought it would be easier if I stood down here. But of course, as I forced the brush up each tube, guess where the ash went?
On you.
Yeah. I nearly quit that job that day. That sucked. All right. What they come up with as an alternative was what they called a regenerative air preheater. Picture this: a big wheel that rotated very slowly. Inside that big wheel were little segment pie-shaped baskets of wire mesh. Each side of the wheel had ductwork that directed the hot gases from the boiler through one side and the cold incoming air through the other side. As this thing rotated very slowly, one side would heat up and pass into the path of the incoming air. This thing was beautiful because when it came time to clean it, you shut it off, you removed each pie-shaped segment with a chain fall, hosed it out with an air hose or a water hose, cleaned it, put it back together, and away you go, fat, dumb, and happy. All right. The big problem with this thing is that it needed electric power for it to rotate. All right. If the electric power tripped, the motor tripped, the big wheel would stop. One side would get really hot one side would get really cold and the wheel would warp and you just killed yourself an air preheater. All right, so you had to pay attention. All right. So on the state exam for second fireman, they're going to ask you, can you name two types of air preheaters? All right. They are the tubular air preheater and the regenerative air preheater. All right. Some people call this a rotating air preheater. That's fine as well, if that's easier for you to remember. All right. Now, the air preheater, what they want you to know is that there's a 1% gain in efficiency for every 40-degree rise in combustion air temperature. So if I increase my combustion air temperature 200 degrees, I get a 5% gain in boiler efficiency. Does everybody kind of get the math of this? All right. So these devices improve the overall boiler efficiency dramatically. All right. Does everybody agree with that? They're good ideas. All right. Now, the only other question they can ask you is this. In the boiler, if you have an economizer and an air preheater, which one is located closest to the furnace?
I'd say the economizer.
You would be correct in saying the economizer. The question, Dave, becomes why? Why is the economizer closest to the furnace?
10 degrees is a lot less temperature to raise for efficiency versus the 40 degrees.
That's not bad, Greg. You're on the right track. You're just not saying it right.
Okay.
All right. And what I think Greg's trying to say is that it takes more heat to heat up a pound of water than it does to heat up a pound of air. In fact, the specific heat of water, you already know. It takes 1 BTU to heat 1 pound of water, 1 degree Fahrenheit, making its specific heat 1. Air, on the other hand, only needs 1/4 of a BTU, 0.24, to heat up a pound of air 1 degree. So you get a bigger bang for your buck if you place the economizer closest to the furnace, the higher heat area. And then any remaining heat is used to heat the combustion air. All right. All right. And I think that's where you were going with that, Greg, you know?
No, that was way off on that.
Hey, you should have just taken credit for it. Said, yeah, I was thinking that, you know?
So its water is,
the specific heat of water is 1. And that means how many BTUs it takes to raise 1 pound of that substance 1 degree Fahrenheit. All right. The specific heat of air, combustion air, is 0.24. All right. So 1/4 of that. All right. And we'll talk about those terms, specific heat, later on down the road, but
so it's easy to heat the air.
Yeah.
it's much easier to heat up air. Yeah. Yeah. Which is why they say, you know, the old forced hot water house heating systems were better. All right. All right. You know, I'm not sure better is the right word, but I guess the water stayed hotter faster or longer, you know. All right, I think that's it. Let's did anybody look at the homework?
Yep.
Did anybody have any problem with any of the homework questions?
I completed it. Stays were the only thing that got me a little bit.
Say it again?
Stays.
Okay. And have you got it now? Remember, stays and stay bolts are the same thing. A stay bolt is a short stay, all right? Boilers with flat surfaces require stays. What boiler type that you're familiar with has flat surfaces?
Fire tube.
Fire tube.
All fire tube boilers, all right?
Where does the scale form in a boiler?
The scale, for anybody remember that? Always below the water line. All right. Let me go through that one more time, just so you get it. This is important because they ask that on every test. If you boil water, what happens to all the impurities?
You go to the bottom.
They stay in the water. So the steam is up here. So none of the impurities are in the steam. You will not form scale on those surfaces. You can only form scale where the impurities are below the normal water level. All right. Anything else on the homework? So what would be your explanation of what an economizer does? Anybody?
They use the flue gas heat to heat up the feed water to its saturation temp.
Okay. Yeah, you can skip that. Saturation temperature utilizes the exiting flue gas to raise the temperature of the incoming feed water. What does the air preheater do?
Preheats the air to feed to the boiler.
Preheats the incoming combustion air by utilizing the exiting flue gas. All right. What does a superheater do?
Heat saturated steam.
It elevates the temperature of saturated steam by utilizing the exiting flue gas temperature. Isn't it a beautiful thing?
Yeah.
What's the biggest heat loss in any boiler?
Stack.
Out the stack. All right. I think we covered everything that's on here. These are the questions that are on the state exam. All right. If you look, for instance, I don't know how I lost that page, but let me, here we go. This is a test from 2020. All right. What's the highest pressure a boiler can operate at?
Maximum operating pressure.
MAWP. All right. Where will you find scale in a boiler?
Water line.
All right, you got the idea. So you can see these questions. What is a longitudinal joint? All right. What boiler type has diagonal stays? All right. Which boiler type has stay bolts? All right. These are the questions that are right off the
So-
state exam.
A water tube boiler and an electric boiler also have diagonal stays?
No, those are the choices they gave you.
Okay.
Remember, the
Yep.
test is multiple choice. So they're gonna throw some ducks at you. All right? They're gonna throw you some wrong answers to see if you'll bite. All right?
Tom, is the third engineer's multiple choice or is that essay?
That's 20 essay questions.
Thank you.
Yep. All right. But you get the idea, right? All right. Let's see if there's anything else we've talked about here. Probably not. A dual pressure controls allowed.
No,
Oh, all right. All right. There's only one electrical question on the second fireman's test. It is, what does the same job as a circuit breaker?
fuse.
A fuse. All right. Isn't that simple? All right. All right. Smallest size of a round manhole. 15 inches. All right. So does everybody get this? I'm going to send you all the state exams that I have so you can look at them in preparation. All right. Before you take the test. I also have them for third engineers. I have them for every license. All right. Everybody gets it. Joe, did you find that useful when you took your second fireman's test?
Oh, yeah. Like, this is exactly what it says. Like word for word. Just like, even if you don't know what you're doing, if you memorize it, you'll pass.
All right. Oh, look, what's the main heat loss in a boiler?
Flue gas.
You get the idea. All right, I've had enough of this for tonight. What about you?
Yeah.
Homework is due on Monday. All right, have a nice weekend. And I'll see you on the other side.
All right, guys, have a good one.
All right, good night.